So finishing up with an exam style question, we have that a 1,500 kilograms car is driving on a motorway at a speed of 108 kilometers per hour. When the vehicle in front of it stops suddenly, there's a distance of 90 meters between the cars. And we're going to assume that the car starts braking straight away, or we're not going to think about thinking time, that is to say the amount of time it takes the driver to realise that the car is stopped. That's also important, but we're not going to worry about that here. We're just going to think pure instant reaction. The driver can immediately start to brake whenever he wants. Which is going to be important in a second. So first of all, we're just going to work out what the kinetic energy of the car is. Then they want us to work out what the work that needs to be done on the car through braking to avoid a collision is. And then they want to know the minimum frictional force that the brakes need to provide to be able to stop the car. So let's start by doing that. So this is our car we're talking about, just drawn as a black dot there. This is the vehicle that stops in front. This is stationary. And they want us to work out what the kinetic energy of the car is to begin with. That is to say, the car that's moving. That's simple enough. We know that Ke is just a half mv squared. But we need to work out what the v is first of all. We've got this 108 kilometers per hour, but you know that we do energy in, well, we do speeds in terms of meters per second. So we need to work out what 108 kilometers per hour is in meters per second. So 108 kilometers per hour. That's 108,000 meters, so times 10 to the 3, because a kilometer is 1,000 meters, meters per hour, which is 108 times 10 to the 3 meters divided by, well, how many seconds are in an hour? There's 60 minutes in an hour times 60 seconds in a minute. So that's going to be, well, we've actually chosen the numbers quite nicely here so that 108 is really just 18 times 6. And again, you can just put this straight into a calculator if you like, but it's nice to be able to see how this all runs out. Times 10 to the 3, and that is 6 times 6 times 10 to the 2 meters per second. We're just going to cancel off some things. So doing that, we see that this 3 cancels with this 10 to the 2, this 6 cancels with this 6, this 18 is really just 3 times that. So we're left with, guess what, 30 meters per second. Great. So now we're going to work out what the kinetic energy is. Well, the mass is 1,500.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.